Okay, so while we were going through the short run chapters in this course, we had skipped chapter 6. We are finally going to be able to finish it. So, before that, a small discussion on chapter 5. Remember that we had made two very strong assumptions in chapter 5, which was that there are only two financial assets, those are money and bonds, and only one interest on bonds. Money, of course, don't pay any interest. Now, it should have been obvious to all of you that these are very strong assumptions, even in Dhaka. So, okay, sure, we don't have the sophistications of the New York Stock Exchange or something like that. But even in Dhaka, there are multiple financial instruments that we can use, different ways of investing our money and saving our money. And so, obviously, these are strong assumptions. And as we have done throughout this course, is that we have introduced a simplified version of the real world to begin our journey. But now we are going to slowly start relaxing these assumptions. So in chapter 6, that is what we do, is we relax these assumptions that there is only one interest rate and there is only two financial assets. Okay. So before that, let me go through an example that's given in the book. And it's a pretty good example. Okay. So in the book, they give us two examples, two cases, one from 1980 and one from 2006 from US. Uh, this book mostly talks about the US economy. So what they give us is, first of all, the T-bill interest rate in 1980 was 10.9%. Okay. T-bills are just a type of bond. You buy a T-bill, and once the maturity date comes, you get back some money in return for holding on to it. And inflation, let's come to inflation later. So T-bill interest rate in 1980 was 10.9%, and in 2006 it was 4.2%. Okay. Now, if this is all the information that's given to us, then what looks very obvious straight away is that borrowing was cheaper. Borrowing was cheaper in 2006, right? Because if you borrowed in 2006, you had to pay an interest of 4.2%. But if you borrowed in 1980, you have to pay an interest of 10.9%. So if this is all the information we have, then of course that would be our conclusion. But now suppose we take a look at the inflation data as well, okay? And what we see is that in 1980, inflation in US was 9.5%. Inflation in 2006 was 2.5%. So effectively, what would happen is that in 1980, if you borrowed $100, after 1 year, you would have to pay back, with the interest rate, you would have to pay back $110.9, right? But during this one year, there would also be an inflation of 9.5%. So would you calculate the real money that you were paying back? Not the nominal amount, which is this, but the real amount. You'd have to divide this by 109.5, and then you get the real payback. And in 2006, if you borrowed the same amount, $100, you would have to pay back 104.2, but this is the nominal amount that you're paying back. In real terms, how much you're paying back is 104.2 divided by 102.5, and that should give you the answer. So I don't have a calculator with me. I'm not doing the calculations, But what you see straight away is that once we bring inflation into it, these are much closer. So even though interest rate was higher in 1980, inflation was also higher. And so the real return that you can expect to get uh, from an investment, or the real interest that you would have to pay back from borrowing from the bank, would is much closer than would initially appear to us. So that's something we are going to, excuse me, something we are going to focus on in this chapter. So straight away, we are going to introduce two things. First, we will talk about something called a nominal interest rate, which is the interest rate that's given in terms of money. Okay, and we're going to denote it by IT, interest rate in period T. And second, we're going to talk about real interest rate. And you all know the difference between nominal and real. Real is just interest rate that's adjusted for inflation. So this is given in terms of a basket of goods. And of course, if you guys have done Eco 102, you guys know what a basket of goods is. We'll denote it with RT. Okay. So now the question is, what's the relationship between these two? How do we find a relationship? The way of doing that is, excuse me. So instead of dealing with actual numbers like 100 and stuff, let's just get a bit abstract. So suppose you borrow, you want to buy something, okay? You want to buy something, and the price in period T of that good is $P in period T. So you want to buy this thing. In the book, the example is a loaf of bread. So you want to buy bread, then you're going to borrow the money to buy the bread. And the price of the bread in period T is PT. Okay. Now, if you want to find out how much you have to pay back in the next period, so we're borrowing in period T, so we will be paying back 1 year later, let's say in period T plus 1. How much will we have to pay back? That is equivalent to, this is the borrowed amount, times the interest that we would have to also pay, right? So this is it. And this is in nominal terms. So to explain that a bit more, suppose you borrow $100 and suppose the interest rate is 5%. So after 1 year, how much do you have to pay back? To pay back 100, obviously, that's how much you borrowed, and also the interest. So that's 1 plus 5%, so that's 0.05. So what we have is 100 times 1.05, which is 105. Okay, so you borrowed 100, and after 1 year you're paying back 105. What's the problem with this analysis? The problem is that we're not taking into account inflation. Okay, now if there has been 100% inflation, then what would have happened is that the value of money would have halved. And so when you're paying back $105 for having borrowed 100, you're really, in real terms, you're paying back something like $52.5, because there has been 100% inflation. If there has been, let's say, 5% inflation, so you're paying 5% interest, but you've also suffered through experienced 5% inflation. So effectively, you've borrowed 100, and in real terms, you're also paying back 100. There's, you haven't had to pay anything extra in inflation. So the way of showing this mathematically would be, first I will have to introduce something called expected price. Okay, expected price. We do not know what the price will be in period t plus 1. So price in t plus 1, which we expected to happen. I need to bring something like this in here. And then what I'm going to do is I'm going to take this. This is how much we're paying back in nominal terms. So remember, how do we go from nominal, to real? We divide by inflation, right? So what I'm going to do is to calculate payback in real terms. What I will do is I will take this nominal payback amount, 1 plus IT. I'm going to divide this by PT plus 1 E. Okay, my expected price. So what does this mean? Let me explain this a bit more with examples. So let's bring this example again. So we are borrowing $100. Interest is 5%. So we expect that we will have to pay back 105 in nominal terms. But now let's bring inflation into it. We expect there to be a 10% inflation. Or let's stick with price. We borrowed this to buy bread, remember? So we can also say this is equal to price in period t. And what we expect price in the next period will be 110. Remember, because there's going to be a 10% inflation. If that is the case, how much are we paying back in real terms? What we are paying back is, same calculation, 100, 1.05. But now we're dividing by 110. And then however much we get. What this tells us is how much of, so if with $100 we had bought one loaf of bread, what this equation tells us is how much of that bread equivalence are we paying back. Okay. So in a simplified example that's given in the book, if we expect, let's do this calculation again. So if we expect that we will have to pay back $10, not expect, I mean the numerator we can calculate. If we have to pay back $10 and we expect the price of bread to be $2, then what we are doing is we are paying back 5 bread equivalents. So this is no longer tied to price level, which can go up or down. This payback now is in real terms. We are actually taking a look at a basket of goods, and we're trying to figure out how much in terms of that basket of goods would we have to So the important equation from this chapter is this. The real interest rate is equal to the nominal interest rate times pt divided by et plus 1. Okay. Or we can simplify this a bit if you guys want to. What we introduce is something called expected inflation, which is equal to pt plus 1e plus minus pt divided by pt. And if we simplify this, what we get is pt plus 1e divided by pt minus 1. And if we plug this into this equation right here, what we are going to get is 1 plus rt equals to 1 plus it divided by 1 plus it plus 1 expected. And now if we simplify this, what we are going to get is 1 plus it equals to 1 plus rt 1 plus it plus 1e. And you guys just simplify this. It's just simple algebra. And what we are going to end up with is real interest rate is not exactly equal to, is close to, similar to nominal interest rate minus the expected inflation. Okay, so a numerical example. Suppose interest rate in the economy is 5%. Suppose we expect inflation to be 3%. So very simple. If someone asks what's the real interest rate, it's the interest rate when we adjust for inflation, what we get is effectively 5% minus 3% equals to 2%. Very, very simple here. Another way of explaining this, suppose you borrow $100, you pay 10% interest, or rather, let's write it at 0.1. And so you expect that you will have to pay back 100 times 1.1 dollar, of course, is equals to 110. However, there has also been an inflation, let's say, of 5%. So if we adjust for that, what will our payback be? Payback is going to be 110 divided by 1.05, which is, what will we get? Let me just pull out the calculator here. So 110 divided by 1.05, we get something like 104.8. So we get something like 104.8, right? So if we had just followed this equation, what we have gotten was that real interest is equal to the nominal interest rate, which is 10%, minus expected inflation, 5%, equals to 5%. See, of course, notice that we haven't said is equal to, we're saying it's very close to. So we are calculating that real interest rate would have been very close to 5%, and that's what we see here, is that actual interest rate is 4.8%. So this equation right here gives us a shortcut of calculating, or at least getting close to the real interest rate that's prevailing in the economy.